Now, if you look at this mass spectroscopy, yeah, it is going to be functioning based on fragmentation. Okay, so they are going to be the molecules. They can be fragmented. Okay, where okay you can actually have okay like fragment over here. Okay, so you can have CH3 plus. Okay, and you can have another fraction which is over here, which is going to be this entire thing, COCH3 okay plus. Okay, so they are going to have fragmentation over there. So you can see the plus over here is 1, and then there is a free radical over there. So it doesn't matter this where plus and free radical, they can be interchange. Yeah, so in the end, why it is important to have plus and so on? Yeah, because of this plus, because there is going to be electric field, okay, in the mass spectroscopy, which they will actually use that charges to move the sample. Yeah, so it is important for the sample to be in gaseous form, okay, and also to be in charged form. Yeah, so this one, if you want to know a little bit more, okay, I think in the beginning of the textbook, okay, they mention about the mass spectroscopy. Maybe you can flick through and just check. Yeah, so that is going to be under AS. Okay, but we are not there. Okay, we are not here to discuss about that. Okay, we just want to know that okay this one can switch. Okay, you can see they can say CH3 plus, okay, and then this one is a free radical. Yeah, so fragmentation, okay, can cause the peak, okay, because this entire thing, okay, you can get it as C3, okay, C3H6O, okay, which is going to be 12 times 3 plus 6 plus 16. So 36 plus 6 plus 16, 42, 16, 58. Okay, supposed to get 58. Yeah, but this 58, okay, can break or fragment to give you CH3, which is going to be 15. So there is a peak at 15, and there is also a peak at 43. Okay, so there is going to be different fragmentations. Okay, from here you can see even okay there are already 3 fragmentations can be there. Yeah, so they are going to be multiple fragments. Okay, but do remember like what I taught you just now, the largest value, which is you see 43, 15 and 58. 58, the largest value will give you the molecular formula. Yeah, so that is going to be useful, yeah, to know about that. Okay, so the next question you can see here, okay, they ask you to look at the figure, okay, and then okay they say that it is going to be a ether, okay, with the formula CH3, okay, CH3O CH3. So they have given you this information, and then they ask they say that predict the mass to charge ratio of a fragment that will appear on the mass spectrum of methoxymethane but do not appear on ethanol mass spectrum. Yeah, so this is methoxymethane. So let's actually look at ethanol. Ethanol is CH3CH2OH. Okay, so when I look at this, okay, they are just telling predict one will not appear. Okay, from here, what I can notice is, okay, if let's say they fragment over here CH3, yeah, there is CH3 here. Okay, there is CH3 over here. If you have, okay, like for example, CH2, I think the one CH3O, yeah. So if you look at this fragment, okay, this fragment, okay, if you look at this fragment, okay, this fragment, okay, is going to be, let's say, predict the mass to charge ratio of fragment that will appear on the mass spectrum of methoxymethane, but do not appear on ethanol's mass spectrum. Okay, I think they're talking about, okay, I think this one is 15. This one is 15. this one is 16. So if you look at this, 15, 12, 14, 16, and 1. Okay. So they are telling that there is 1, okay, do not appear. Okay. I think the one that do not appear over here, okay, on ethanol, because the ethanol, okay, if they have the CH3, they will have CH3, no problem. Okay. But okay, ethanol will not have this entire thing. Okay, because ethanol has CH2OH. Okay, so it means that they are talking about CH3O plus. Okay, which is going to be 12 plus 3 plus 16. Okay, which is 31. Yeah, that is correct. So this 31 will not appear. Okay, instead they are going to get CH2OH plus, which is going to be 12 plus 2 plus 16 plus 1, 14, 30, 31 also. Yeah, that is 31 also. Let me check. CH3O. Yeah, CH3O. Still 31. Yeah, still 31. Okay, but okay, in this case, the one, okay, that the one that is responsible, I think the question is not structured properly. The one that is responsible is going to be the CH3O plus. Okay, this one. So give the formula of the ion responsible for the peak in your part A. Yeah, so this one. Okay. Now, the next question is, okay, they say that for C, okay, look at the mass spectrum of ethanoic acid. So let's look at ethanoic acid. So this one is mass spectrum, yeah. So do remember it's not NMR, yeah. So mass spectrum, you can see here, okay. The one that is going to be, let's actually see whether you are still following. Jackson, what is the MR for this molecule? Possible MR, no need to calculate. Wilson?
44.
Why 44? I told you, yeah, first time when you look at it, yeah, look at the biggest number, yeah. The biggest number is 60, yeah. Most likely that is your MR, yeah. So let's actually calculate, okay. You see 2 carbon, 2 times, okay, 2 times 12, okay. And then plus 3, plus 16, plus 16, plus 1, okay. 24, okay, plus 32, plus 1, plus 3. So that's going to be 34, 35, 36, 36. Okay, you have 60. Okay, so it means that, okay, I know that this is going to be the fragment that you have at 60 over there. Okay, it belongs to, okay, please remember you need to still write down CH3 COOH plus. You still need to write down plus. Okay, you still need to write down plus. So molecular ion. And you have multiple fragments. Yeah, the one that is 15, okay, normally is this one. Okay, CH3 is the 15. You can calculate 12 plus 3. Okay, so that is going to be CH3 plus. Okay, and then okay, 43 and 45. Okay, let's actually see, calculate. If this is 15, C and O 12 plus 16, so it's going to be 28. So this one is 28. The OH is going to be 16 plus 1, 17. So if they want, okay, 45, okay, 45 is this plus this one, okay, 28 plus 17. So it's going to be 45 is going to be representing for COOH plus. Okay, that's for 45. How about 43 then? Yeah, 43 is these two. Okay, 15 plus 28 is 43. Okay, which is I put it as CH3CO plus. Okay, given, can you understand this? Yeah, it's like breaking it into puzzles. Yes, small jigsaw puzzles, and then it will be easier to see if you can fragment them also and put the numbers. Okay, it will be easier to solve. Yeah. Now, we also have what we call as high resolution mass spectra. Yeah, so that one please read. Yeah, so this one I just want to introduce to you only. Yeah, no need to go too in detail. Yeah, so they will give you more information, but the one that is really important is this one. Okay, this one, okay, normally I don't teach you on how to memorize the formula. Yeah, I teach you how to derive. Okay, but I think for our case, yeah, I'll just go through a little bit. Yeah, see whether if you really cannot understand, then just memorize the formula. Yeah, but the formula will not be given in your exam. You need to apply. Yeah, so that is what we call as m+1 peak. Yeah, what is m? M is the molecular peak, yeah, molecular ion. This is M. The 60, okay, is M, the biggest one. Yeah. So if you have M+1, it means that there is a peak at 61. Okay, there is a peak at 61. That is called M+1. We also have M+2, and then M+2 is 62. Okay, M+1, we have M+2. We also have M+4, which is going to be 60 plus 4, which is going to be 64. Okay, we will go through into that. Yeah, so what does it mean and so on. Okay, so if you look at it, yeah, so the M+1 peak. Okay, we do have M+1 peak. There is always a small peak after the molecular ion peak. Okay, which is going to be M+1. So one of the carbon atom, okay, is carbon 13. Okay, it means they have found out. Okay, don't ask me how. Okay, they found out. Okay, that one of the carbon atom is going to be carbon 13 if you go through the mass spectrometer, and the percentage, okay, is going to be 1.1%. Okay, it means that if you have a molecule, okay, 1.1% of that molecule, a small fraction of that, okay, contains carbon 13. Okay, one of the carbon atom is carbon 13, so 1.1%. Okay, so this one you memorize. Okay, but okay, you can use this information. Okay, you can use this information to find out, okay, the number of carbon. Okay, number of carbon that you have in this particular molecule. The formula, okay, is, okay, N using this information 1.1. Yeah, so N equals to 100 divided by 1.1. Okay, actually there is a way to derive this, but I don't want to actually focus on that. Okay, so just focus on, okay, using the formula. Yeah, where how to actually work out the information, how to get the formula and so on. Try to figure out, okay, on your own. Okay, if you're really interested to know, okay, please do let me know. I will explain to you. Yeah, so here, okay, the N is going to be 100 divided by 1.1. So basically it's using this information. Okay, if you times with the abundance of M+1 and abundance of M plus, you are going to get the number of carbon atoms. So if you, sorry, if you use the formula, okay, an unknown compound, okay, has a molecular ion peak. Okay, this is the abundance of M plus, okay, which is the 54.5. And then it has M+1, okay, which is going to be 3.6. So of course you're not going to get 100% because there are others, yeah, that are involved. How many carbon atoms does this unknown compound contain? Now, in order to get this, okay, just apply the formula. Okay, N equals to 100 divided by 1.1, abundance of M+1, which is going to be 54.5. Okay, 54.5. Okay, sorry, M plus 1 is 3.6. Okay, 3.6, okay, divided by 54.5. Okay, and you will get the value which is 6. Okay, how we get this? Okay, basically it depends on the 1.1%. Okay, it is counted from abundance of M plus 1, okay, divided by abundance of M plus, okay, then times 100%. Okay, using this value, using this information, okay, you can actually get the formula. Okay, 1.1 divided by 100. Okay, I think let's actually not focus on deriving, but there is a way to derive this, so I'm not prepared for the deriving, so here, okay, if you look at it, okay, which is going to be, you are going to get 6. Okay, what is important over here is 100 divided by 1.1, not 1.1 divided by 100. So 100 divided by 1.1, okay, M plus 1, okay, and then M. Okay, M plus 1, then followed by M. So that is going to actually help us to identify the 6 carbon atoms. Okay, so if let's say we try to apply this formula, okay, you see here how many carbon atoms are there in this hydrocarbon. Okay, this is the part that is very important, which I want you to focus. Okay, which is the part that they will ask you in an exam. So hydrocarbon, they say that they have 84, and then M plus 1, okay, is going to be, okay, this is M, okay, this is M, so 62 and then 4.1. So how to calculate? N, okay, 100 divided by 1.1, okay, times M plus 1, 4.1 divided by 62. Okay, if you calculate, you will get the value which is going to be 6. Okay, just double check. Okay, someone help me to check. Okay, do you get 6? Okay, using this. Okay, and then they ask you what is the molecular formula. Okay, molecular formula, they say that mass to charge ratio is 84. Okay, so 6 carbon. Okay, so just 6 carbon. Okay, 6 carbon, and then hydrocarbon. So most probably we do not know whether they are going to be C6H2N plus CnH2n plus 2. So 12, okay, plus 2 is 14, or maybe they have CnH2n. So it's C6H12. We don't know. So what you can do, you can calculate, see whether which one will give you 84. Okay, so if I calculate, okay, I think better use this one. 6 times 12, okay, plus 12 times 1. So you are going to have 72 plus 12. I have 84. I think this one. It contains, okay, it contains unsaturated carbon-carbon bond. Hold on here, guys. So it contains an unsaturated, okay, carbon-carbon bond. Okay, so I can identify, okay, certain things. Okay, and then what is the molecular formula? So my molecular formula is C6, okay, H12. Okay, and then I know that, okay, this hydrocarbon, okay, does not decolorize bromine water. Okay, so if it is do not decolorize bromine water, but they are CnH2n. Okay, so this one last time we have learned. Okay, CnH2n alkene, it can be alkene, but alkene must decolorize bromine water. Must decolorize bromine water. So another one that I mentioned to you many times, okay, it can be a cyclic compound. Okay, a cyclic compound with 6 carbon. So it means that they are not going to have, okay, double bonds. Okay, it's just going to be like this. Okay, so you have 2 hydrogen each. So this is going to be the compound that they meant over here, which is going to be, they will have C6H12. Okay, but there is no double bond. Okay, so this is going to be the molecule. Confirm. Christopher, can you follow?
Yeah.
Okay, this is all what we have learned last time. Yeah. So now, okay, let's actually move on to this. We have settled with m+1. So if you recall again, yeah. So m+1, what I want you to know, okay, is you need to know that the formula 1.1%. Yeah. Carbon 13 is 1.1%. So you need to know how to apply the formula. Equals to n equals to 100, okay, divided by 1.1 times the abundance, okay, abundance of m+1, okay, divided by abundance of m. Okay, if you use this formula, you will be able to calculate the total number of carbon. Yeah, so that is going to be important for m+1. Yeah, so let's actually look at m+2 and m+4. Now, this m+2 and m+4, okay, will exist, okay, whenever we are talking about chlorine, yeah, chlorine and Br, okay, because, okay, chlorine and Br, we have this chlorine 35 isotope. Okay, we also have chlorine 37 isotope. Okay, so if let's say, for example, if I have Cl2, okay, Cl2 is Cl35 and Cl35. So my M value, okay, is 70. Okay, my M value is 70. But because there are isotopes, Cl can have Cl35 and Cl37. So that is going to give you, if I add, it's going to be 72. I also will have Cl, 37 and 37. If I calculate this, I am going to get 74. Okay. So M plus how many? M plus 2, 70 plus 2. M plus how many? 70 plus 4. M plus 4. That is the meaning why we have M plus 2 peak, M plus 4 peak. Yeah, because there is isotope involving for Cl. Yeah, so the same thing, okay, will apply for Br 79 and 81. Cl is very common. Yeah, for Br is going to be maybe we don't use it often. Yeah, Br also 79 and 81. We have also learned about this. 25% is 37. Yeah, 75% is 35. Okay, and then for Br, okay, the percentage are the same. Okay, so this one, okay, all this information can be used if you want to calculate relative isotopic mass. Last time we have already learned about this. Okay, but this is an extension to it. Yeah, so M2 plus 2 is going to be 1/3. Okay, so if it is let's say they say like this, if the M plus 2 peak is 1/3 of the height of the M peak, yeah, so it suggests the presence of one chlorine atom per molecule. Yeah, so if it is going to be, okay, M plus 2 peak, so it means if this M plus 2 peak, yeah, because I think 35 and 37, yeah, M plus 2 involve 35 and 37. So remember, according to the ratio, yeah, the 35, okay, is going to be 75%. So 3 to 1. Okay, that is the peak is going to be 3 to 1. So there is going to be, the peak is 1/3 of the height of the M peak. Yeah, so if they compare. And then, okay, if M plus 2 peak is the same height, yeah, for the M peak, then it is most probably bromine. Yeah, so let's say for bromine is going to be the peak, okay, if they compare, okay, the M plus 2 peak, you compare, it's 50%, it's the same, yeah, 50%, 50%, same height, then most probably is going to be bromine. But no need to go so much in detail. I don't think so they will ask you about that. Okay, last time, yes, they do ask. Okay, and then for dichloromethane, yeah, they are going to have different ratio. Yeah, the dibromomethane ratio is going to be 1 to 1. Yeah, so you can read through this. Okay, they are going to have all these kind of different combination. Yeah, different combination of Cl. If you have Cl35, Cl35, 35, 37, 37, 35, 37, 37. So of course you have 1, okay, because two of them, yeah, so two and this is one, okay, so the ratio is 1 to 1, yeah. And some questions over there, okay, which you can actually go through yourself, okay, and then some applications and so on, okay, some questions over there, okay, but I'm not interested with that so much, yeah. I'm more interested on how to apply, yeah. So if you look at our past year paper, okay, that we did yesterday, okay, I'll just highlight one part that we did yesterday, which I told you that, okay, no need to do for now. This one. So let's see whether I can get rid of this. Okay, maybe. Now, that we have discussed about this question. Yeah, this one, all this. Yeah, I do not know whether we discussed everything. Yeah, I think we discussed some. Yeah. Okay, up to here. Yeah, I think we discussed up to here. Yeah, so here, okay, if you look at I just want to show you about this one. Okay, the beginning part. So the combination, okay, provides a powerful tool for analysis. Yeah. So use the data to show the number of carbon atoms. Remember yesterday I told you the number of carbon atoms is 3. Yeah. But now I want you to learn how to calculate already. Yeah. So this one, okay, how to calculate. I already taught you how to calculate. Okay. So it's supposed to be n equals to 100 divided by 1.1, okay, times abundance for m plus 1, which is 2.5, okay, divided by abundance of m, which is 74. Okay, can someone calculate? Give me the answer.
3.
Yes, that's why 3. So this is the part that I really want you to know, yeah, for this mass spectrometer, because this is the part that I still suspect, even though they remove it, yeah, from the A2, I still suspect that they will give you something like this, okay, so which you should know, yeah. uh, and I think it's quite cool, yeah, because I think if I'm setting a paper, if I don't want to give the information straight to you, yeah, I want you to calculate the number of carbon, yeah. So of course, if I'm the examiner or setter of the paper, yes, I will put it there, yeah, because there's nothing wrong for me to put it there because it's still under AS, yeah. So I suspect that it will be there, yeah, even though they have removed it. So that's why we went through, yeah, that's why we went through, but not in detail, yeah, because I don't think so they will focus on that, yeah, maybe but 1-2 marks, yeah, possible, yeah. So something like this, okay, it's possible. And then the rest, I think when we did this, okay, I hope you remember, let me look at the previous paper, if I'm not mistaken, this one, yeah. Let me check the one we did last time. I think this one. I don't know which one I was using. Okay, I hope you can still remember a little bit about what I discussed. Okay, I think when you do this, okay, I think the answer, okay, for the structural formula, let's say draw the structural formula of G. This one. I think this one, if I remember correctly, I stopped at CH3, CH2, and can someone tell me what is the structural formula that we discussed up to yesterday? Or I can check the marking key. While I search for it, okay, I don't know which one. Yeah. So remember yesterday we did up to here, okay, which is going to be, we found out up to CH3, CH2, COOH. Yeah, that is the structural formula of G. Now, several structural isomer exist. Yeah, draw the structural formula of isomer G with only two absorption. So now, if I look at it, okay, I will see that I will have total of how many absorption? I will have one absorption here, another environment. So total, I have three absorption, yeah, which I don't want because they want only two. So I need to come up, okay, with a structural isomer. So the first structural isomer that I came up is going to be the normal one, the carboxylic acid, which I know for sure is not what they want. Okay, so this is not what they want. So I need to rearrange so that I get something that only give me two absorption. So no need to think so much. The only way I can have an isomer of this is by putting the carboxylic acid, I change it into ester. Yeah, which is going to be, you put the C double bond O and then you put O, and instead of H over here, you put the CH3 here. So I did something like this, which is an ester. So why I did like this? Because when I check the proton environment, okay, the hydrogen environment over here and the hydrogen environment over here are all the same. Okay, sorry, not the same. The hydrogen environment here, here, and here, this is one environment. Okay, because the carbon attached to O. But the hydrogen environment here is going to be the carbon attached to carbon with double bond O. So these are different. So there are total two absorption, okay, because two different environment. So we are looking into this part. And then they ask, use the data booklet to suggest where this absorption happens. Okay, so when I look at this, okay, I know that, okay, maybe, okay, I have the one that the hydrogen attached to carbon that has C double bond O. I have the hydrogen attached to the carbon attached to O. So let's actually look at the information that we have over here. Okay, so if I look at the information that I have over here, this is going to be one of the information, which is going to be CH3 attached to O. And then there is going to be another information, which is going to be the CH3 attached to carbon, okay, with double bond O. Yeah, so these are the two informations, okay, that can help us, okay, 2.2 to 3, okay, and then 3.2 to 4. Okay, so I put over there. These are the one that will actually help me, okay, to identify. So here also, I think I already do it over here, okay. So it will actually help me, okay, around here, okay, and so on, this one. Okay, so this is going to be, you are going to solve based on that. Okay, so it's an extension to what I taught you yesterday. Yeah, so now it's 8:33. Okay, of course, okay, I don't have time to go through all this. Okay, but okay, if you look at it now, okay, this one just ignore, because now you should be able to do everything. Okay, in summary, yeah, in summary, uh, we are officially done, yeah, with the syllabus. Yeah, so all the information, okay, required for the syllabus is done. Okay, but okay, if you look at what we have learned today, okay, it's going to be, today we just focus, I think the only one thing that if let's say within this 1 hour lesson, yeah, the only one thing, if let's say there is a takeaway, is going to be, I want you to look at this formula, n equals to, okay, n equals to 100 divided by 1.1 times, okay, the abundance, okay, of m plus 1 divided by abundance of m. Okay, we have learned a lot of things. Yeah, the fractionation. Yeah, you have fractions. Okay, and then you have the molecular peak and so on. So many things we have learned. But okay, the one that is very very important. Okay, that I spend 1 hour today, which is extra with you, is just to focus on this. Okay, which will give you 2 marks in your exam. Okay, which is definitely important, okay, to secure the remaining 12 marks in your exam. So which is very crucial. Yeah, which is very crucial. So I covered that part as well. So now, okay, you should know how to apply NMR proton, how to apply NMR, okay, the carbon 13 NMR. Okay, and you should know how to calculate this. Okay, what is m plus 1, okay, m plus 4, and so on. If let's say there are some questions on that. Okay, but that is going to be the essence of it. Okay, but another one more thing, yeah, which is quite important. I mentioned about CdCl3. Why you use CdCl3 instead of CHCl3? Yeah, to minimize, okay, the interference, okay, towards the NMR spectrum. Yeah, because if you use the deuterium, okay, which is going to be even number hydrogen, okay, they are not going to give you peak in the, okay, in the NMR spectrum. Okay, but they still give you, yeah, 80 ppm. Okay, at 80 ppm, which is we ignore. Okay, Sharon, okay.
Yes, sir.
Okay, so this one, okay, I think it's time already. Yeah, that's all from me. Okay, see you guys. Okay, bye.
Hi, sir.
Bye, sir.
Yes, sir.
Bye, sir.